page 77 from the homework. Do you think it's proportional or not? So simply yes or no question, and then it does say explain why. So if I take paper out of a copy machine, that's a standard 8.5 by 11. Okay, and if you're not done, you need to have your book closed, of course. As you're stacking paper on a scale, let's say, are you adding the same weight every time you add the piece of paper?
Yes.
Why?
Because all paper weighs the same.
Because all paper weighs the same. Okay, all that paper off the copy machine is going to weigh the same. So is it proportional? Yes. Each sheet is adding the same amount of weight. Or however you'd like to phrase that, but you do need an explanation. Now, if you stack books, your library book, your math book, your science book, are they all going to weigh the same amount?
No.
So is it proportional? No. Why?
The books' weights aren't the same as all of them. They're like, an individual book isn't the same.
The books will not weigh the same amount. Okay, question 2. Every package of a certain toy contains 2 batteries. Letter A. Kellen, would you read it, please? Are you there?
Yes. Every package of a certain toy also includes 2 batteries. Are the number of toys and number of batteries in a proportional relationship? If so, what are the 2 constants of proportionality? If not, explain your reason.
All right, so if every pack contains 2 batteries, is that proportional? Yes. Okay, and then it says, what are the 2 constants of proportionality? So I should have 2 numbers. Well, one is simple.
25 and 2.
1 is 2. It gives it to you right here. And then the reciprocal of that, of course, is 1/2 or 0.5. I like to write it as a fraction because then I can see the reciprocal. So let's write the equation. So how many batteries would I need if I have 1 toy? How many batteries would I have?
2.
2. How about if I have 2 toys?
4 batteries.
How are you getting that?
19.
You're taking the number of toys times 2. 2 times the number of toys. So 2 times 2 would be 4 batteries in 2 toys. 10 toys would be 20 batteries, 2 times 10. So what's the other equation now? Well, I flip the letters around. And what do I do to the 2? Reciprocal it. So those are your 2 equations. And again, you have to have the variables on there. Question 3. Looks like Lynn is 3 years older than her brother. So she better be 3 years older the whole time, right? So if Lynn is 6, her brother is 3, still 3 years older. If Lynn is 15, her brother is 12. And how about if her brother is 25? 3 years older, right? Adding 3. Is it proportional?
The brother doesn't add a 2/5 of an age, like 2/5 of a year every time the sister's birthday comes around.
Right now it's 2/5, right? 2 divided by 5 is 3 divided by 6, 2/5. 12 divided by 15, 2/5. 25 divided by 28, 2/5. If I take 3 times 4 and get 12, is 6 times 4 15? A lot of different ways to realize it is not. Okay? It is no. It does say explain. You guys have had a couple good explanations there. Their age are not proportional. Could say each year you add 1. And we said never add. Number 4. Do you agree or disagree with the student that says this is not a proportional relationship? Disagree. We did say that if the variable is on top, it is proportional. So y equals x over 9, variable's on top. We said that was fine. Now, he does make a good point that it looks like you're dividing, but remember the other way to write that, dividing by 9 is the same as 1/9 times something, so those two things mean the same thing. So it's still a number times a variable. They just chose to rewrite it as a dividing problem. So disagree, and it doesn't even say explain on that one, but we did go into a little detail. Last question. Scale factor of 2, what side lengths could we have? So it gives us these 4. Scale factor of 2, read.
B and D.
You double, you would get 6, 8, 10, and 12, and I'm circling the ones that are available there. It looks like 6 and 8 is right on. Any questions on that? All right. You can go ahead and take your iPads out and do the warm-up for today. 2.9 warm-up.